Welcome, everyone, to another Silicon Labs product podcast. I'm really excited about today's episode. I have Tiago Monte. He's a great friend of mine at Silicon Labs, and he's really started to take a focus on the developer experience with his background in apps engineering and in Bluetooth primarily. He has a great deal of experience with the customers, and now he's working to try to improve that. So thanks again today for joining, Tiago.
Hey, thanks, Kyle. Thanks for having me.
So as I mentioned, your new role recently has been to focus on the developer experience with how they interact with Silicon Labs products. What are some of the improvements that you've really prioritized in the last year?
Right, that's a great question. So we released Studio V5 in September this year at the Works With conference, which is actually a fundamental part of that, revamped developer experience that we've been having at Silicon Labs. So some of the things that you will find there is that, a lot of the customers that we have, they start their Silicon Labs journey with a hardware kit, right? So the idea is that everything is going to be based on the target that you choose. So what you purchase a kit, you plug that in, you bring out Simplicity Studio 5, install your SDKs that you need to work with that kit. That can happen automatically. And then it will give you this contextual information, sort of putting the information in front of the customer to basically avoid the customer to have to go around and fish for the information from different places. So they will see, the sample apps that they need to have for that kit. They will see the documentation. We've also been doing a lot of improvements within Studio 5. There's a re-architected software at the SDK level. So that allows the customers to bring new software pieces much more easily than before. So as soon as they launch a sample project, they will have new project configuration tools. So they can very easily, go and pick up, a UART driver, a display driver, all kinds of things that will, get much faster into, their prototype application. Oh, in fact, you can actually start from, even a Blinky application that doesn't have any wireless functionality and just add Bluetooth on top of that. That's just how, modular the software has become. So really, really flexible. Then, of course, you have, on the Bluetooth, more on the Bluetooth side of things, you have dedicated tools, for example, the GAT configurator, which is a tool that allows you to visually build up your GAT database and then automatically generates the code that implements the database. And one thing that we've now have included in the latest Studio update that came out just a few days ago is also on each of the sample applications. You have README with all the information about what does this sample app do, how do I test it. You get that in the launcher view, but also when you launch your sample app, you get that as an HTML formatted page that just gives you a very quick introduction to the sample app, where to get more information afterwards. And last thing that we also introduced was a tool called the Bluetooth NCP Commander, which is actually it comes to replace an existing tool that we had called the BG tool. And this tool allows you to control an NCP target. So that's a Bluetooth device flashed with an NCP firmware. So it runs the full stack, but it's for an architecture where the application runs on the host side. So this new tool, well, first of all, of course, at the UI level, it's very well aligned with the rest of the Studio V5 look and feel, let's say. But it brings, a lot of improvements in how the controls are distributed around different panes, and also it brings a new console where the interface with the NCP is binary, but of course humans don't talk binary, so customers have to input ASCII-based commands. And as they input these Bluetooth API commands into this prompt, it has IntelliSense, so it automatically recommends which commands they need to put in there and the parameters, with even built-in documentation that explains which parameter, what you need to have there, what the options are. So there's been a lot of improvements. These are just a few of them. I could fully go on for quite a few quite a few more minutes, but I think these are like the ones that are worth highlighting.
Absolutely. And you joined me in Austin, I think it was a year and a half ago, for some of the first initial planning meetings to revamp Simplicity Studio. So that work has definitely shown. I've used the latest version, and you mentioned NCP Commander. That's brand new, but the look and feel of it is really, really cool. So I'm looking forward to using that. But all the examples and just the flow and all the information is presented in a new and fresh way. So you did a great job. So that's a good first step. But you did mention kits. And I think, with your background, you have a great understanding of the importance of development kits and evaluation kits. Can you talk to us? I think there's a new kit. Why don't you introduce to the audience what this new experience is that you're working on with the developer kits?
So yeah, we launched a new kit about a month ago called the Explorer Kit. It has the BGM 220 module. So this is the first kit, in this sort of new category. The kit really aims to reduce the barrier of entry to any customer who wishes to experiment with Silicon Labs Bluetooth offering. So it's extremely affordable. But I think what's key about this kit is even though the price tag is very appealing, we still did not trade off some of the key features that make this kit to be as intuitive as easy to work with any of the other kits. So namely, it still has onboard debugger. So we didn't get rid of that. And that's actually very, very crucial because that is what allows you to plug in that kit and have the same experience in studio as if you had any of the other kits, like a Thunderbolt BG22, for example. So it still gives you, the contextual information. You get your demos ready to go, your sample apps to get started. So that kit, it brings also the features that typically come with the onboard debugger. So you'll still have the PTI. The PTI stands for Packet Trace Interface. So that allows you to receive basically you see all the traffic that goes through the radio, and then you can bring that into Network Analyzer, which is a tool on Simplicity Studio, and then decode the Bluetooth traffic. And if there's any issues on the link, then you'll be able to very easily identify them with this tool. You also get the VCOM. So the VCOM is basically a USB to UART bridge. Very typically embedded developers, their first level of debugging is printf messages or some sort of logging that they want to capture on the PC. So the VCOM offers exactly that. So it offers the link to the PC where you can open a terminal and collect that information so you can analyze it later on. And I think the new thing that we're actually bringing here is we recognize that especially within BLE and Bluetooth, that customers want to get very quickly to sort of a rapid prototype. And a lot of the people who are currently developing with BLE, they don't have any. They're mostly software developers, right? So they don't necessarily know how to build hardware, and without hardware, we can't really prototype anything. You'll just sort of try to simulate things, but it's difficult to get to a functional prototype or a proof of concept. So we looked around and we figured that there's quite a few interesting hardware ecosystems, brewing up. So we've added to this kit a microbus, so that gives you access to the, I think currently at over 900 click ports from Micro E. And we've also added a quick connector. So that is from SparkFun. It's basically an I2C connector that allows you to sort of interlink sort of a chain of boards that you can purchase from SparkFun, but also there's some compatible boards from Adafruit as well as Seed Studios, which have a little bit different connector, but you can easily get the conversion cables between the Quick and the Seed Studios own connectors. So really, what we try to do here is that make sure that customers, because we've been investing so much on the software side to make it more modular, easier to put together, and we're trying to do the same thing on the hardware, so that you can create your proof of concept with off-the-shelf hardware without having to do anything by yourself from scratch. So you just you know what you need, what kind of sensors or input devices, displays, whatever you need, just buy it off the shelf from these third-party ecosystem providers, plug it into the kit, and then just focus on your application software.
Yeah, I'm really excited about the third-party connectors. I think that's going to open up a lot, Tiago. I know working with other manufacturers, I've seen that in the past. So now that we have the ability to allow our customers to include those third-party boards into their prototyping, that's going to be huge. So kudos to you guys for adding that to the development experience.
Yeah, we think so too. We hope that the customers really find this valuable and they can go ahead and start prototyping and get to their, well, eventually what we're trying to do is accelerate their time to market.
Exactly. So now that you have the IDE revamped with Simplicity Studio version 5, you have this really cool new Explore board with the third-party connectors for hardware integration. What resources are you planning, and what resources do you have for customers if they want to start using this Explore kit?
So that's a great question. The price tag of the kit is really not at the cost of DX, right? That developer experience. You have the same things, the same building blocks as if you had, a more advanced kit or even going for your own custom hardware. So we have, of course, there's the hardware documentation, and we also have a getting started guide, which explains, which demos you can use from Simplicity Studio. And of course, some of these, the third-party ecosystem providers, so MicroE has their own SDK, and from SparkFun, they typically have their own controller boards, which leverage Arduino IDE. So those are ecosystems where we're not supported, but we have tried to bridge that gap by writing down porting guides. So we looked at the micro SDK APIs for basically it's really for the peripherals, right? So what you have on the micro bus is UART, SPI, I2C, GPIO, just toggling and reading input and output. And the same thing on the Arduino. So what we wrote a very detailed porting guide between the micro SDK APIs, the Arduino APIs, and how they map out into our own Silicon Labs, SDK platform API. So when you want to do a UART, and because if you go and you purchase these third-party hardware boards, oftentimes it will sort of link you towards an Arduino IDE project, for example, that runs on a SparkFun board. So when you look at that application level code, you will see all these Arduino API calls. So you can just sort of look at those, map them out with very easy to use tables, and then you will see what you need to use on the Silicon Labs software side, because that's eventually going to be, the environment where you're going to, start working on your, let's say, more professionally driven application moving forward. And of course, what we're trying to do now as well is roll out new examples. So we're selecting from all these, this immense offer of boards from Microe and others, and selecting some that we know that we have that our devices are very capable within those applications. And we're working with internal teams to roll out more examples in our GitHub application examples repo. And moving forward, of course, all of the improvements that we make overall, they will of course they will be leveraged by all of our kits. So we don't have sort of different kit classes that map out to different DX flows. Everything is the same. So regardless of which kit you choose to start with, you're always going to have the same experience. So it's going to be very consistent, and that gets carried over also for the custom hardware development. So you have this sort of seamless flow across the DX when from the moment you start until the moment that you go and ship out your application, out the door.
Yeah, that's great that you guys are focused on that. But that API guide that you were talking about, I think it's also really, really important, because as much as you mentioned, we have our GitHub now repo, we have new examples that you guys are coming out. We can never do everything everybody wants, and so having that API translation for existing projects from other manufacturers, or maybe existing projects from a developer, that's going to be huge, because we just can't anticipate what everybody wants to do.
Yeah, that's true. And of course, there's challenges, having supporting those ecosystems and those SDKs. At the same time, we cannot as support ourselves because we have to focus on our own devices and our own SDKs. So we try to find a middle point that can, of course, get customers faster, without not being fully, although not being fully supported, it will still allow customers to more easily, if they need to develop device drivers for a particular board, then they should do that much more easily than just sort of not having anything, of course, and having to figure out everything by themselves. At least that gives them some guidance on how things will work, coming from a micro SDK example or an Arduino example into the Silicon Labs software environment.
Sure, sure. Well, that's the Explorer kit sounds awesome, but I think at the end of our episode, I think you should talk a little bit about the difference that the user could get if they still evaluate using the starter kit. What's the big difference, and why would you, if you're consulting a customer, why would you consider an Explorer board, or hey, you should really consider the starter kit? What would be sort of your criteria to use the starter kit?
Right. So I think that the first thing to highlight is, eventually all customers will end up doing their custom hardware. I mean, if they're serious about their project, they will, of course, develop their own hardware. And actually, that's where the starter kit comes in. So the starter kit has features that you can use on your custom hardware. So, of course, it has onboard debugger, just like the Explorer kit. The difference is that you can use that in debug out mode. So you can actually use it as a standalone debugger. You don't, it's not something that only works for the radio boards on the kit. It also works for your custom hardware. It has the advanced energy monitoring, which means you can measure the energy consumption on your custom hardware, and you can visualize that with the energy profiler on Simplicity Studio. And then, of course, it also has the VCOM. So all of these things actually are available on a single 10-pin connector, which we call the Mini Simplicity connector. So it gives you debug capabilities, with SWD physical interface. It gives you the AEM, it gives you the VCOM, and it also gives you the PTI. So you also get the packet trace interface for your custom hardware. So that's is really important because we don't want customers to sort of realize how valuable these features are, and then when they go to their custom hardware, they kind of lose them because they can't use them. But that's not the case with our kits. Everything can get carried over, let's say, for the custom hardware. And there's a few other things which I think are worth mentioning. So it also has an expansion header on the side. If you want to prototype around the starter kit as well. Of course, the Explorer kit is focused on prototyping, but nothing prevents you from prototyping around the starter kit just the same way. Has a coin cell holder, so you can do sort of standalone applications, carry the boards around. We even have a very cool range test application with a mobile app where you can walk around with the boards and see how the RSSI changes with the distance. Of course, you need the coin cell for that. And there's another feature that sometimes customers get a bit puzzled about. So it has an Ethernet interface. And why? There's a few things why this is quite fundamental. So basically, the Ethernet interface gives you access to the board controller, and if you have a starter kit on your network, you will see it on Studio. So you can access the kit just as if you had it connected with USB. And why this is very powerful is that, as you know, Silicon Labs, has, industry leading software stacks for mesh technologies, for Zigbee, OpenThread, for Bluetooth Mesh. And of course, Mesh implies a lot of devices. If you only had a USB interface, it would be difficult for you to create, distributed test network. So that's where Ethernet becomes really, really essential, because you can, of course, Ethernet, typically you'll have a lot of devices, a lot of places where you can plug in these kits, and then you can create, mesh test networks using this. And in fact, our offices around the world, our office in Boston and Finland, they have large test network deployed based on the Ethernet connection. And we even have application notes that talk about our mesh network performance. And really, the only way to gather all that data was with this feature that sometimes it might not be to understand why it's there, but it's actually pretty critical. And we have a lot of customers who have bought the boards in large quantities to deploy similar networks so they can actually run their own tests for their applications.
Yeah, and you mentioned there's an app note that kind of walks through that test network, and so that
Exactly.
yeah,
Yeah.
so I think customers that take advantage of that, it's ironic that for a wireless network you wire everything up, but
Yeah, that's true.
but when you're responsible for the reliability, that's why you wire it up, because you want to test it before it's truly wireless. So it's great. It's a great feature, and it's great that you highlighted that.
Yeah, I mean, it's just a backend, right? It's just a backend data network, and once you collect the data, then you can do whatever you need with it. But when you have it, that's really critical link. And without this, I mean, you just mentioned those app notes, so I mean, there's a lot of data on that. From how many devices and then different configurations of the network. Sort of inserting, let's say, points of failure and how the network reacts to that. And of course, when a customer sees that, it gives them a lot more confidence because they know that Silicon Labs really test their mesh networks to a very extreme, hundreds of devices, different configurations. So I think that's something that through this kit we can actually gather that data and allow customers to do the same thing if they want to deploy their own test networks.
Yeah, and I've heard it over and over again that we definitely provide the customers with more than they've seen with other suppliers out there. So great job, and I think our customers are really going to benefit from all the hard work you're putting into the developer experience. So that's all the time we have for this episode. Tiago, I really appreciated the time you spent. I think I learned a lot about what you're working on, and I think our listeners are going to understand a little bit better about what they can get with our our tools, with our Explorer kit, and a great ending with the starter kit. So thanks for the time today.
All right, thanks, Kyle.
All right. Well, and thanks everyone for listening. And until our next episode, please take care.